Hi guys, let us introduce ourselves. This is Lukman, Fika, Adeline, and me, Javelin. The purpose of this experiment is to prepare a colloidal solution and observe its dispersion effect, to prepare gel, and to purify a colloidal solution through dialysis. We are preparing apparatus and chemicals that needed to be used in this experiment. For the part 1, put 75 ml of distilled water in a beaker and heat to boil. Pour 2 ml of 30% iron trichloride solution into the hot water and observe the appearance of the solution. Label this solution as a solution A. Let solution A cool down to room temperature. As you can see, solution A has a darker color than 30% FeCl solution provided.
As for Tyndall effect, 0.1% starch solution is prepared by adding distilled water into 10 ml of 1% starch solution into 100 ml conical flask until the calibration mark is reached. Next, for 0.01% starch solution is prepared in the same way by diluting 10 ml of 0.1 starch solution. After that, 6 clean test tubes are prepared and each test tube about 2/3 full with one of the following solutions, that is 1% starch solution, 0.1% starch solution, 0.01% starch solution, 1% sugar solution, potassium chromate solution, and solution A. Each test tube are placed separately in front of the light box. The amount of light which penetrates through the solution is observed. Tyndall effect is the ability of the particles of a mixture to scatter light, that is, to make the path of a ray of light passing through it visible. Heterogeneous mixtures, which are suspensions and colloids, show Tyndall effect while it shows no light in a true solution. In this experiment, only 1% of starch solution show no Tyndall effect because the light does not scatter through the solution, while for the rest of the solution, it shows Tyndall effect because the light scattered through the solution.
Add 2 ml of saturated calcium acetate solution into a 50 ml beaker and immediately pour 10 ml of ethanol solution into the beaker. Do not stir the mixture solution and the result is the presence of gel. Put 3 ml of 5% starch solution into a test tube and then follow it by 3 ml of sodium chloride and HCl solution. Cover the open end of the test tube with a piece of the pre-soaked cellophane membrane and fasten it tightly to the side of the tube with a rubber band. Turn the test tube upside down and clamp it in a small beaker containing water. The water level in the beaker must be below the level of the rubber band. After 13 minutes, take a small volume, about 2 ml of the distilled water from the beaker and add the necessary reagents to the test for the presence of starch and sodium chloride. Test for starch. Add 3 drops of dilute iodine, and the result is the change of color to yellow. Test for sodium chloride. Add 2 drops of silver nitrate solution, and the result is the change of color to cloudy. Repeat the above procedure 1 until 3 using 6 ml potassium permanganate instead of starch solution and sodium chloride solution. After 5 minutes, take a small volume, about 2 ml of potassium permanganate. The result is the change of color to light blue.
Pour 5 ml of solution A into 3 different test tubes. Label each of the test tubes as E1, E2, and E3. Add 2 drops of sodium chloride solution to E1. Add 2 drops of sodium sulfate solution to E2. Add 2 drops of magnesium chloride solution to E3. Shake the solution in each test tubes and let it stand for a few minutes. The precipitation occurs only in E2. At the end of this experiment, we can conclude that colloid has properties of having Tyndall effect, forming gel, undergoes dialysis, and have difference in size of the suspensions and solution. State the 4 different types of ions, which were mixed separately with solution A in all test tubes in the experiment above. The 4 different types of ions are magnesium ion, sodium ion, chloride ion, and sulfate ion. Which ion is the most effective in coagulating solution A? The most effective ion in coagulating solution A is sulfate ion. The higher valency of sulfate ion causing coagulation, the higher the coagulating power of an electrolyte. The sulfate ion more electronegative than the chloride ion. Thus, the sulfate ion can donate more negative charge or electron to the positive charge of the solution A that causes the solution to be accumulated. The accumulated charge in the solution A will coagulate and form a precipitate.